Hello everyone. So today we will see about epoxides. Epoxides, we can also name them. These epoxides are nothing but just cyclic ethers. Like if you see, this is one type of ether known as methoxymethane or dimethyl ether, in which these are two separate methyl groups. Okay, and in between them there is one oxygen. If these three make one cyclic ring, then it is known as epoxide. Let us consider CH2, single bond CH2, single bond O. These alkyl group along with the oxygen, they make a cyclic ring, and this is the ethereal oxygen. Okay. Combining all of this, we get a epoxides. So the general structure of an epoxide is, so these two carbons connected in a cyclic manner to an oxygen and two substituents along with that carbon. So this is a general structure of epoxide. Okay, if you go to particular example, this CH2 single bond CH2 single bond oxygen, this is known as ethylene oxide, or the IPAC name is 1,2 epoxy ethane. Due to presence of two carbon atoms, carbon 1 and carbon 2, this is known as 1,2 epoxy ethane, and the epoxy group is at 1 and 2 position. And if we consider this CH3, CH, CH2, and then the epoxide ring, this is known as propylene oxide, and the IPAC name is 1,2 epoxy propane. Propane due to three carbon atoms, 1, 2, 3, and the epoxy group is with one and first and second carbon, so it is known as 1,2 epoxy propane. So this is one cyclic epoxides. If we consider this one is just like this cyclic epoxide. This is known as ethylene oxide 1,2 epoxy ethane, or we can see the heteroatomic naming, it is known as oxyren. If you see four membered ring in a cyclic manner and connected as an epoxide, this is known as oxytane ring. Okay, these are examples of some epoxides. So we can also as we have studied in the preparation of alcohols with the epoxides little bit, we have shown that how these epoxides are prepared. So let me repeat once again repeat this, how these epoxides are prepared. Okay, let us see. These epoxides are prepared by reacting alkenes with pore acids. What are pore acids? In which there is a peroxide linkage between the carbonyl carbon bond to let us do the structure like R C double bond O O OH. This one is peroxy linkage. Oxygen single bond oxygen. And if we consider the examples, pore acids, one is benzoic acid, and another one is meta-CpBA. This is known as metachloro benzoic acid. you see the structure of benzoic acid, perbenzoic acid, this is like this: benzene ring, carbonyl group, oxygen, single bond oxygen, H. This is perbenzoic acid. If we consider metachloroperbenzoic acid, the structure is like this. That perbenzoic acid group, and in the meta position, ortho meta, and para, in this meta position, one chlorine group, that is electron withdrawing in nature, is attached to the benzene. Okay. This okay, let me clear the canvas and I will see. If I consider this, let us reaction with an alkene. Let us consider a reaction with an alkene with this perbenzoic acid. You can say AR C double bond O OH. This oxygen, this benzoic acid, this oxygen is electrophilic oxygen. This oxygen is electrophilic oxygen. So the reaction mechanism follows as this attacks to the oxygen and the lone pair of oxygen attacks to the carbon, this carbon, and there is formation of C double bond C single bond C bonded to oxygen, to substituents plus benzoic acid ArCOOH. This is the formation of epoxy. Okay. By these methods, reaction of alkenes with perbenzoic acids, just like perbenzoic acid or metachloroperbenzoic acid, this produces epoxy. Okay. Next, we will see physical properties of epoxides. These epoxides are not much stable compounds. They have very weak bonds. If you see the bonds in epoxide, CH2 double bond CH2 single bond O single bond O. If you see ideal tetrahedral angle, like carbon, 4 hydrogens are added. This is one ideal tetrahedral compound. The angle between two bonds, that is known as 109.5 degree. But here, as this is a trigonal structure, okay, the angle is around 60 degree. So instead of 109.5 degree, we are getting 60 degree. So there is so much of angle strain. Like if you see the cyclic rings, the 5 and 6 membered rings are comparatively stable, but the 3 and 4 membered rings are unstable. So this instability is due to, instead of getting 109.5 degree, 109.5 degree, they are just getting 60 degree. In case of 4 membered rings, they are getting 90 degree. So there is so much of angle strain. Due to this angle strain, this bond is weak, so they easily break. Okay. If we then we will see the chemical properties and the reactions. Okay, first of all, the chemical property we will see. First, this is acid catalyzed, and then it is reacted with various nucleophiles. Okay. In the first reaction, we will see hydrolysis. So the mechanism for this reaction will be due to presence of, let us say, CH2, CH2O. This is acid hydrolysis, so there will be one H plus ion. Due to availability of lone pair, the lone pair will first attack to H plus ion, and this oxygen will be protonated. This will form OH plus. Now there will be attack of nucleophile. This nucleophile will attack from this carbon and breaking of this bond. Okay, so this will form CH2 CH2OH. There is positive charge. Initially transfer of 2 electrons, so it is neutral, and to this there will be bonded of OH2 OH2 plus, and in the next step there will be a proton minus of H plus, and there will be formation of ethylene glycol, CH2OH, CH2OH. This reaction we have seen in the preparation of diols. We have already seen this reaction. Okay. Next, the reaction acid catalyzed reaction with alcohols. So in the first step, this oxygen will be protonated and there will be formation of CH2 single bond CH2 OH plus. The next step, the alcohol that will act as nucleophile and attack to the carbon, and there will be breaking of this bond and there will be formation of CH2OH single bond CH2 single bond O C2H5 and H plus. Sorry, the plus will be on the oxygen. In the next step, there will be deprotonation and formation of CH2OH and CH2OC2H5. Okay, next we will see the reaction of epoxides with haloacids. These are collectively known as haloacids. So let us see if in the first, if this reacts with HCl, this HCl will break down to H plus Cl minus. So in the first step there will be protonation and there will be formation of CH2 single bond CH2 OH plus. In the next step, the Cl minus will act as a nucleophile and attack to the carbon and there will be formation of CH2Cl and CH2OH. Similarly for HBr, there will be formation of CH2Br single bond CH2OH. Similarly for HCN, there will be formation of CH2OH single bond CH2CN. The CN compound here, this will break to H plus and Cn minus. The Cn minus will act as nucleophile. Okay. So the next we'll see the reaction of epoxide. This is known as ethylene oxide with acetic acid. So acetic acid, this acetic acid will break down to CH3COO minus plus H plus. So in the first step there will be protonation. This will react with H plus and there will be formation of one protonated product, or that will be not product, this protonated intermediate. In the next step, the CH3COO minus that will act as a nucleophile and attack to the carbon, breaking of this bond and there will be formation of CH2OH single bond CH2 O C double bond O CH3. This is ester group. Okay, so in the next step, okay, up to this we have seen all the mechanisms. So if you are watching this video, so now pause it, see this reaction, try to complete this reaction as far as you know the mechanism, and after completing the reaction, play the video and check if you are correct or not. Okay, so next I am doing the mechanism. In the first step, due to presence of this H2SO4, we have seen, or else mentioned this H plus. In the first step there will be protonation, into this attached CH3H CH3 single bond CH3. This will react with H plus and the first step will be protonation. A single straight line, that means this is methyl group. Okay, let me mention also methyl group. This will be OH plus. Okay. In the next step, there will be attack of nucleophile. In the next step, there will be formation of carbocation. Okay. There are two possibilities. This will break in this way, step A, or this will break in this way, step B. In this process, so step A, so there will be formation of C to this methyl group, hydrogen, OH, single bond C, methyl. In this process, so step A, and in this process, so step B, the breaking of bond from this side. So there will be formation of C, two methyl groups attached, formation of OH, carbocation, ethyl H. So now the question arises, reaction will proceed through which step, either step A or step B. So now if you see, here is the production of tertiary carbocation. To this carbon already 3 carbon atoms are attached, but here the production of secondary carbocation. The tertiary carbocation is more stable than secondary carbocation, so the reaction will proceed through this step. Okay, so there will be formation of this carbocation, and after this formation there will be attack of nucleophile C2H5OH. This will attack here, and there will be formation of CS3 CS3 OC2H5, and to this CS3 CHOH. So this will be the major product. And if this reaction proceeds to this, there will be formation of one minor product. Okay. The next step, this is all about acid catalyzed ring opening. We have all studied acid catalyzed ring opening. Next we will see base catalyzed ring opening of epoxides. Okay. In the base catalyzed ring opening, let us see one reaction. If this ethylene oxide or this epoxide react with ethanol in presence of sodium ethoxide, this sodium ethoxide is a strong base and a strong nucleophile. So in the first step, if you see the reaction mechanism, in the first step there will be attack of nucleophile. This will react with C2H5O minus and Na plus. This O minus act as a nucleophile, and there will be attack on this carbon. There will be formation of CH2. Okay, let us consider to this carbon CH2 single bond CH2 O minus, and to this there attached will be OC2 H5, and this O minus there will be formation of Na plus. There will be to this Na plus, and from the alcohol C2H5OH HO C2H5, this will abstract and proton abstraction H plus, and there will be formation of C2H5 O CH2 CH2 OH. This will be the major product. Okay. Next, if we see the reaction of C6H5OH of phenol with this phenoxide ion, sodium phenoxide. So the reaction will proceed through same way, similar method. This O minus will attack to the carbon, and there will be formation of C6H5O CH2O minus Na plus, and there will be this proton from phenol, proton abstraction, and there will be formation of C6H5O CH2 CH2OH alcohol. And if this react with base like ammonia, so in the first step the lone pair from ammonia will react, attack to this carbon, and there will be formation of CH2 single bond CH2 NH3 plus and O minus. If you write this separately, NH3 plus, this will be NH2 single bond H. The next step, this will be proton abstraction, and there is formation of CH2 single bond CH2 NH2 and this OH. This will be the major product. Okay, this is ammonia. Instead of ammonia, if we react with primary amine or secondary amine, so there will be formation of product like CH2 one alcoholic group OH group to this CH2. There will be abstraction of one proton from oxygen, and there will be formation of NHR. This is the major product. And if we react this with secondary amine, there will be formation of CH2OH CH2N R2. So this cannot react with tertiary amine, because for this reaction there are at least one hydrogen in the bonded to the nitrogen. So in tertiary amine this is R3N, so this cannot react with tertiary amine. So in the next reaction we will see reaction with Grignard reagents. The Grignard reagent, if we see RMgx, this is Mgx plus and R minus, so this act as a nucleophile. So this will attack to the epoxide carbon. Let us consider one reaction like CH2 single bond CH2 or ethylene oxide react with CH3MgBr. So in the first step this nucleophile are attacked to this, and there will be formation of CH2 single bond CH2 single bond CH3 O minus MgBr plus, the followed by hydrolysis, acidic hydrolysis. So there will be abstraction of proton, there will be formation of CH3 CH2 CH2OH, sorry 3 carbon CH2OH, propanol. So if we react Grignard reagent with ethylene oxide or oxygen, there will be formation of primary alcohol. Okay, so this is all about the reaction of Grignard reagent with epoxides. So in the main thing to notice is in the Grignard reagent, this alkyl group acts as nucleophile, and there will be attack of nucleophile. Okay. The next step, reaction with lithium aluminum hydride followed by hydrolysis. Okay. So if we react with ethylene oxide, so there will be formation of this AlH4 minus. Generally this hydride ion attacks, and this hydride ion will attack for, let us consider this attack for this carbon, and there will be formation of CH2 and attack of this hydrogen. This makes O minus and lithium plus. So upon hydrolysis there will be formation of CH3 CH2OH, primary alcohol. Okay. So now the question arises, if this is the reaction, what will be the product? There are chances of formation of two products. Okay, if this the hydrogen hydride aluminum hydride attack to this carbon or attack to this carbon, let us consider this step A and step B. This attacks this, if this proceeds through step A, there will be attack of this carbon, and the formation will be, product will be, if this proceeds through step A, the product will be CH2OH CH single bond CH3 single bond CH3. But if this proceeds through B, there will be formation of CH3 single bond COH CH3 and CH3. Now the question is, which one is the major product? This one is the major product because this is one hindered site due to bonding of two methyl groups. This is hindered side, or there is steric hindrance. And this lithium aluminum hydride, the formation of aluminum AlH4 minus, this is a bulky group. So due to as this is a bulky group, so this will attack to less hindered side, which is this side. So the reaction will proceed through B, and there will be the formation of this major product. Okay, this is all about epoxides. Initially we have seen preparation, the reactions, acid catalyzed ring opening and the base catalyzed ring opening. If you have any doubts, let me know in the comment section. Thank you all.